What's up, guys? In this video, we're going to be talking about some of the extra tooling or utility functions that get shipped with maci. These tools just help provide an extra convenience for varying requirements you might encounter. Whether it's formatting data or easily getting a hash of files, the tooling provided, and more will be added in the future, just help simplify common needs. Currently in version 1 of maci, there's only a couple of tool functions available. So let's dive into the first one, which is formatting your data using the tooling function clean format. The clean format function helps format structured data to have a nice cleaner output. Whether it's dictionaries, lists, tuples, or sets, it formats that structured data to a more clean, human-readable structure. This is mostly especially useful for nested data. That way it can be represented over multiple lines with indentation. So let's dive in and see what I mean. So as you can see, I've gone ahead and created some nested dictionary data with the first level of data here, second level here, and we even have a third level. And so right now, this is expressed and written out in Python, and we can easily see what's going on with each level of structured data. But as soon as we print this, what is it going to look like? So let's run the code. And so we see everything in line, which is still not bad. I mean, this is not terrible nested data. It's still pretty easily understood because there's not that much. But imagine having a massive set of data where it gets pretty large and hard to distinguish. Having it all in line would be difficult to differentiate. So this is where clean format steps in. So we'll just type in maci.clean format. Pass our dictionary data in there. And before we run it, let's go ahead and hover over it. As you can see, clean format, it's pretty straightforward. All you need to do is pass in a dictionary, a list, or a tuple, or a set, and it'll handle everything for you from there. And that's the only argument you need to add. So as soon as I run this, let's go ahead and raise this up. You can see all of our data is nicely and neatly formatted. In fact, looks exactly the same way that we see it in Python here. This feature can be extremely useful if you're looking at data returned from an API, or large sets of data from a configuration file where you need to actually neatly format it and structure it so it's human legible and distinguishable. Now, hovering over this, the only other option you can change is the indentation level. So if I were to change the indentation level, you can set it to, let's say, 3. And so if we run this, you see it'll change by 3 levels. But note, each level of the indentation level is equal to 4 spaces, which is more congruent with Python standards, having 4 spaces in your white space. If I change this to 0, it'll all be touching the first part of the new line, but you don't have to use this at all because the default is 1, which is typically fine for most cases. Now, of course, this works for any sub-level of structured data. If the data is not a dictionary, so let's try a tuple. And within that tuple, let's try a list. And within that list, let's try a set. Oops. And so now if we run this, raise it up higher, you see it's performing the same exact operation where the tuple is here. And then in the last element there is the list. And then the second element within the list is actually the set, and it continues the same structured design as you would expect. So this is a very powerful and extremely useful tool for structured data within Python, so you can get a nice, clean, formatted output. And of course, because this is returned as a string, you can store this to a file if you wanted to. So if I take this, let's go ahead and grab our output. And instead of printing, what we'll do is just do a simple dump raw. And we'll just create data.out. And we'll store our output as a string. And we'll go ahead and run this. So as soon as I run this, it created a brand new file called data.out. And if I jump in here, you can easily see our structured data stored in this file. So that's it. That's clean format. Very useful tooling function for your structured data to get a nice, clean, organized format in your output. Now let's move on to the hash functions. So currently with maci version 1, there are 3 tooling functions available for hashing. And the first one we'll go over is simply just creating a hash of your data. And it's conveniently called create hash. So if we just simply do maci.create hash, we now have access to the create hash function. But let's go ahead and create some data we want to hash. It could be anything. Let's just do a simple list, 1, 2, 3. Now the create hash function tells you what kind of data it accepts. So you can put in a string, bytes, an integer, a sequence of integers, and a list, a tuple, or a set, or even the range function and a boolean. Currently, those are the acceptable types that you're allowed to pass in order to get a hash. And then there's some options below, which we'll go over as well. But if I wanted to get the hash value of this list of data, all I need to do is pass it in. And that's it. I'm going to go ahead and run the print function, because this is going to return a string of the hash. And the characters within the string is going to be in hexadecimal. So if I run this, as you can see, there's our hexadecimal based hash of that data. And if I run this again, of course with hashing, the value doesn't change. But you see how easy that was to get a hash of the value without having to create your own code to generate a hash of some data. Now currently with maci version 1, the hash that you're going to get returned by default is going to be a SHA-256 hash, which is currently a really good and strong industry standard. However, if you'd like, the API does expose the ability for you to change the algorithm of your choice. So if we hover over this, it should give us all the other options that we have access to. We have the default, which is SHA-256, but the other options are SHA-512, 384, SHA-1, and MD5 if you still need to use that, which, believe it or not, is actually still widely used in some applications. So as you can see, if we just specify the hash algorithm, it requires a string, and if we wanted the MD5 hash of this data, we can run that, and you see that it returns the MD5 version of that hash. Of course, if we wanted SHA-512, we can get that as well, which is going to be much larger, and so on and so forth. Now, the other parameter option that you have access to is called encoding. The default is UTF-8. I'm not going to go over this. I have not gone over this in this series because if you know what encoding does, then you know what to expect. If not, I would definitely look it up and look into what encoding does for your data. But that's it. That's how simple it is to use the create hash function to get hash of your data. But the next one I want to talk about is creating a hash of your file data. And the files one actually have special partner functions that work together, and they make it really straightforward and easy to get the hash of the data in your file, and then later you can easily compare that hash and determine if the file has changed. Alright, so I've gone ahead and created some simple variables, one pointing to our mygame.save file, which is the example we've been using throughout this series in different scenarios, and I created a new file name that we're going to use to store the hash of our data, which is the hash of our mygame.save file, and this will be created automatically. So if I wanted to get the hash of my file data and store that hash, I simply need to use the create file hash function. So I'm going to write like this, create file hash. And if we hover over this, we see that the first argument that it requires in the first parameter is file to hash, and then the second one is file to store hash. And those are the only two required arguments you need to pass. So I'm going to go ahead and pass my source file and my destination file, and that's it. So now if I run this, we see a new file was created. And then we open it here, we see there's our stored hash data of our file. And something you may notice, which is important to understand, that this format is using the format or syntax of maci. So it has our variable name or attribute name with the regular assignment operator to point to this string, to assign to this string. So of course you could just import this file using maci and access the hash data if you want to. That is optional and totally acceptable. Or if you actually wanted to compare the hash of that data, you simply need to use the partner function, which is compare file hash. So I'm going to comment this part out because our hash has already been created. And now at some point in your code, if you wanted to actually compare the file hash, if it's changed or not, we can simply run maci.compare file hash. We'll do our source file and our destination file again, and that's it. Now I'm going to go ahead and print this because this function returns a Boolean. So if we hover over that, you see it returns a Boolean. And that's actually going to tell us if the hash has changed since the last time it was stored. So if we run this, currently it's returning true. And true means that the hash of the source file and the hash of the stored hash file are the same, and they have not changed. So therefore, the integrity of the file is good. Now if I come in here and make even one small change, let's just change the character of knife here in the items, and now if I run this, it should return false, and it does. That's because the integrity of this file has now changed. And depending on how you set it up, and this is just an example that we're using, but this could be useful if you actually want to check if this game save file has been modified, right? And if it's been modified, whether it's a configuration file or game save file, doesn't really matter. If the integrity of the file has been modified, then this can be a really useful function to determine that automatically. And you see how easy it was to set it up. All we did was provide a source file and a destination file, and of course you can store it wherever you want. And as long as maci is aware of that destination file, it can easily compare that data and determine if something's changed. Now currently, in maci version 1, compare and create file hash are using SHA-256, which is currently the industry standard for good hash values. So if you hover over this, you can see that the default value is SHA-256, and if we move over this, it should be the same thing. Now this is important to note because if you change one of these, they both need to be matching the same hash algorithm that's being used. So please ensure to remember that if you do want to use a higher one or lower one, make sure that both of these functions are referencing the same hash algorithm in order for them to partner together accordingly. But if not, the default is totally fine and is already using good industry practice. Now we've already gone over the hash algorithm when we talked about creating a hash of our data in code. But again, with encoding, as mentioned in previous videos, if you know what encoding is, then you know exactly what to do with it. But if not, I would definitely look it up. It's not going to be demonstrated in this video series. Okay, so the last thing I want to show you is a little bit extra information on the create file hash function. You might be wondering, well, if create file hash creates these hashes, that's great, it gets stored to a file. But what if I don't want to store the hash to a file? So create file hash, if we hover over it, always returns the hash no matter what. That actually is mentioned here. Every time you create a hash of the file, it will create the new file and store it there. But this function always returns a string of the hash data after it's hashed the file, just in case you want to use it for your own purposes. So if we were to print this out, I'll get rid of this for a second. Not going to use that anymore. So this is going to rerun it and overwrite the data, but that's the hash that we had before. And as you can see, it's being printed to the terminal as well, but it's also being stored in this file. But if you don't even want a file to be created in the first place, you can simply set the destination argument to none, and it won't create a file at all. But the function will still return the hash regardless of your source file data. As you can see in the parameter, you can optionally pass none in there in order to disable creating a destination file entirely. So if I remove this just for demonstration purposes and run this, you see the hash still gets printed to the terminal, but a new file was not created. But that's going to go ahead and wrap up this video. Hopefully these tooling functions have been useful to you. Thank you so much for watching, and take care.